యా, మీది వస్తుంది ఫేస్. నాదే ఎందుకో తెలియదు, రావట్లా.
Hello.
Good morning, ma'am.
Am I audible?
Yes, sir.
Yes, Louise.
A very good morning to everyone and hearty welcome to an expert talk on role of statistics in machine learning, organized by the Department of Mathematics, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. I'm Dr. G. Ravikiran, coordinator of this webinar. Before commencing this event, I take my privilege to invite you, today's guest for the meeting. Firstly, I welcome Professor M. Shashikala Garu, Associate Dean, School of Computer Science and Artificial Intelligence, SR University. She is with all of us today to motivate us with her words of wisdom and experience. Madam, I respectfully welcome you. Also, it's a great delight to welcome our guest and speaker for today's program, Dr. Praveen Kashyap Garu, Senior Data Scientist, NADFirst Private Limited. I'm very grateful for his kind consent to grace this event. Sir, I respectfully welcome you, sir. And it is my pleasure to invite our Associate Head Mathematics, Dr. B. Ravinder Garu, who is the motivation to take up this program. I welcome you, sir, for this landmark event. Now, I request our Associate Dean, Shashikala Madam, to speak a few words on this occasion. Madam, over to you.
Now, a very good morning to one and all. Firstly, I welcome our today's guest, Dr. K. Praveen Kashyap, Senior Data Scientist Thank you for accepting our invitation, sir. I hope today's session will be very useful to all the members attending this session. Coming to the department and School of Computer Science and SI University, I just wanted to highlight few of the points related to our SI University. SI University Warangal has banked 98 NIRF ranking in engineering category 2023, All India first rank among private institutions 2020, ARIA first rank, NAC A grade and NBA Tier 1. The university is headed by Professor Deepak Garg, Vice Chancellor. He is a distinguished professor in artificial intelligence and known as one of the top voices in the country of AI. He is on the mission to make SI University as a model for private university education in the country. School of Computer Science and AI is offering BTech with 8 specialization in cutting-edge areas in engineering program BS and MS, and 3 MTech programs in CSE, AI and data science, and PhD programs with 40,000 monthly stipend to full-time scholars. And school has 4,000 plus students and 90 plus faculty, 100% placements, 200 plus papers, 60 plus patents, and 2 plus cross funding projects. And also school is associated with many industry collaboration tie-ups like Microsoft, AWS, Cisco, Divyasri, and also some academic collaborations with foreign universities like UMass Lowell, University of Central Missouri, University of New Haven, St. Louis University, University of Missouri, Columbia, and we have best faculty from premier institutions. And I'm happy to say that recently Department of Mathematics is also integrated with School of Computer Science. A part of this Department of Mathematics is also conducting many events, and I hope a part of this event today, it is going to help the researchers and the academicians a lot. And now I request our Ravi Kiran sir to take over the session. Thank you, sir. Thank you for the invitation.
Thank you very much, ma'am. Now I request Dr. E. Suresh Reddy Garu to introduce the chief guest to the audience. Suresh Reddy, sir, please go ahead.
Good morning, sir. Good morning, everyone. I'm delighted to introduce Praveen Kashyap. I'm delighted to introduce Dr. Praveen Kashyap, our esteemed senior data scientist at NatFirst Private Limited since December 2022. Praveen brings a wealth of experience, having served as an assistant professor at VIT Vellore until December 2022 and as an ad hoc faculty at NIT Calicut for 6 months in 2020. With a PhD in mathematics from the Defense Institute of Advanced Technology, Pune, and an integrated MSc in mathematics from the University of Hyderabad, Praveen's expertise extends to fluid dynamics, machine learning, viscoelastic fluids, boundary layer theory, and numerical solutions using MATLAB, Mathematica, and Python. Praveen has an impressive research portfolio with 11 publications and the communication of 3 papers. Notably, he has played a pivotal role in the Truthin project, contributing to the design and deployment of machine learning algorithms. His accomplishments also include the maintenance of product databases. Please join me in welcoming Praveen Kashyap, sir, a distinguished professional in the field of data science and mathematics. Dr. Praveen, the floor is yours. Please take over.
Thank you so much, Dr. Suresh. Thanks for the invitation. So like I said, I was in academics, and then I saw an opportunity to really apply what we have learned. So I joined NatFirst last year. Thank you once again for giving me this opportunity, Dr. Suresh. So let me take over the session. So is my screen visible?
Yes, sir.
Okay. Oh. So yeah. So today, okay. So today I'm here to talk about the role of statistics and machine learning. So this is regarding how the statistics is exactly used in machine learning, right? So I'm working with NatFirst. It's an Orange People company. It's a company in San Francisco, headquarters. So it is there in 63 countries as of now. So we're trying to expand more. So this NatFirst is a child company of Orange People. So we are a health tech company. So we'll look more into it as we go along. So these are the contents that we're going to cover today. So we'll talk about what is data science, what is this all hype about, and what is data science, etc. Like who are data scientists, and what do we exactly do. And then we'll slowly go into the artificial intelligence that we have been hearing for so long, and what are machine learning techniques, and what are the applications, different kind of applications of machine learning, and what are the top use cases, and what are the generally used packages for the Python, etc. And what are the different types of learning in machine learning. We have different kind of classifications, and we'll go through that. And then we'll talk about the popular machine learning models, or the general kind of problems, machine learning problems, that the domain and its limitations. And then we'll slowly look into how statistical modeling is necessary to improvise the machine learning models that we have been using for. And once we set up a ground for statistics, we always have some kind of metrics to say how accurate is your model. So we go ahead and talk about the validation of how do you take the data sets and how do you split them, and how do you talk about your accuracy of your model. So going ahead, so the first thing is like what exactly are we going to see in this first section is that what is data science and why all this excitement about. So you all know that if you go out, Google knows better than you. So if you're trying to, if you're coming to college and going exactly at 5 o'clock every day, if you're going home, it'll tell you that the destination from here, from your office or from your college to your home is this much of distance, and it will take this much of time. It gives some kind of a reminder like that. So it studies the data is the study of data is so important that it will help you in your day-to-day lives. The predictions are much accurate than what we generally do on ourselves. Okay, and then we'll talk about where does the data come from, and how the data is analyzed, and what exactly do we do in data science, how do we analyze the data, or what kind of predictions do we make. And that we're going to see in how we do the data science. So we'll try to answer this question, like how to do this data science, and who exactly are data scientists. And we have data engineers, and there are some ML engineers, there are different kinds of roles in it. And we'll briefly talk about what data scientists do. Okay, and then we'll talk about the role of statistics and data science. So, what data analysis is not something that we look on today. So it has been there for a while, and it has been there continuously, right? So why? Because for suppose if you're trying to look into some kind of grains, okay, if you're trying to distribute grains, then you will try to see that how many people got grains and how many people did not, and then you'll try to analyze when you're getting some more grains. Even in ages ago, you'll still have the relevance of looking into the statistics. The statistics started. So if you're trying to see if there are 3 apples and 4 apples on different days, so you'll try to find an average of, okay, generally you'll try to get 4 apples or something. So that is the general intuitive behavior of statistics that we have in ourselves. But looking at it, if you're looking at the more modern statistics, R.A. Fisher, Reese Fisher is Ronald Fisher, sorry. Ronald Fisher is one of the major scientists who have started the design of experiments. So he's a polymath, he worked in different kind of fields. And then slowly there is a quality control by Deming. And then Peter Learn has started how to conduct a business by using intelligence systems. And then in around 1977, there is exploratory data analysis, and you'll try to see what are the kind of different statistics that we can get onto some kind of data, and then how you can actually improve your own systems. And in 89, there is an advancement in the business intelligence, and then we have 97, we have machine learning, and say like 96 is we have Google. So it is one kind of revolutionary that we had. Yeah. So, and then we have the big data coming up. So then there are further more predictions to that, or the improvements in data analysis. In 2000, from 2010, maybe the data science took over many things because it has applications from facial recognition or like voice recognition and different kind of other activities, especially in the financial and health sectors. So where do we get this data from? So basically, we get the data from everything, like whatever is most of the things that are happening online. So every click you make, every page you see, so all these things are like a big chunk of data. But what to take and what to not to take is a very important question for a data scientist. Okay, then you have say something like user generated data, something like you might type some comments and Facebook or something like that. Based on that, people do sentiment analysis. That's the basic thing that people do. And then you have Internet of Things. So you have and uh, scientific computing. For the scientific computing, so you can find anomalies, or you can size. You can also find if you have a tumor, you can try to predict if it's a what uh, tumorous, I mean, carcinogenic tumor or not carcinogenic tumor. So yeah, so let us talk about what is data science. So data science is a multidisciplinary study where it's a blend of computer science, mathematics and statistics, and uh, the domain knowledge or the substantive expertise, as we call it. Basically, that you need to have some, obviously, the programming skills. You need to maintain your databases, and then write optimized code so that the data is streamed properly. So these are the different kind of problems that we have over there. But as a data scientist, you have to see how accurate is your solution, and you have to bring in perfect mathematical models or like machine learning models, whatever is apt. So sometimes it might be rule based. So sometimes it might be just a simple machine learning technique. Sometimes we might have to require deep learning techniques, etc. So you'll have to classify the problem of how complex it is, and then you have to take action. So for that, you need a good knowledge on the domain so that you can actually judge if the results are getting right or not. So in totality, so this artificial intelligence is like the big mother. And in the artificial intelligence, there are several other algorithms which are artificial intelligence algorithms which are not machine learning. So machine learning is like a subset of that, and in that, deep learning is a subset of the artificial intelligence, as you can see it on the screen. So what exactly is machine learning? So machine learning is something which adopts or sense the kind of predictability, and it will act on itself. Okay, so that's when you're trying to say like, for example, if you're trying to use some kind of software to write, say like to correct your program. So the machine learning or the artificial intelligence that we're going to use is more or less, say something like ChatGPT is like the recent um, exploration of how generative transformers can be used. So in that, you have carefully seen that it will try to give you the programs, and most of if when you're writing a program, it's like you're trying to automate something, and then this machine learning is something like it will actually automate the automation process. So that is where the machine learning is so powerful. So where you can actually replace a lot of people with say like one or two main people with working with say something like ChatGPT, or because it is already doing a lot of work for you. So you have AI assistants. It's not just so you have other applications from say something like Meta, right? That like Facebook, they have their own LLMs. So these are called large languages models. So these come under, say, like particular deep learning techniques that we'll build later. So how does it start, and how is the machine learning used in different kind of cases? So digit problem is the most common problem that people will generally see. So like you write a handwritten digit, and it will try to find out what exactly the pin code, etc. Right? And then you have speech recognition, natural language processing, say something like a sentiment analysis or anything. And then you have computer vision, and then you have robot control, and then you have sensors taking in data and working on and improve on themselves. So this is where the machine learning is generally used in the group. If you look into the further examples, what are the major sectors that are affected? So you will try to see the financial sectors and healthcare and the marketing and sales. The government also uses, if you'll try to implement some kind of a policy, it'll try to collect the data back and try to see how many people are actually getting this benefits, and then you can revise its policy to make its uh, policy much efficient. So that is where the machine learning comes in. What are the top 10 use cases? So obviously health care and the medical field is one of the most and uh, uh, pioneering um, thing that is happening right now, because everybody needs a good health. And then how do you use in health tech? You can use a patient diagnosis. Say like if you, like we spoke about, if you're trying to see the size of the tumor, you'll try to see if it is carcinogenic or not. And sorry, if you're trying to see what are the um, what else example? Yeah. So you can also see that if you have, say, something like you some kind of reading, say I have a high BP, so you'll try to see what is the general. So some athletics might have a very low BP like 65, or low pulse like 65, etc. Whereas a normal person would have, say, like 70 to 80 or something. So you'll have the complete data. You'll try to diagnose if where the patient exactly stands based on the different kind of parameters. And in finance, you'll have something like fraud detection. If somebody else is actually making payments on behalf of you, you would definitely see if that is actually this person who is actually taking, because you might not be doing a 1 lakh transfer in general. That might be a trigger point, but it might not also, you might also, some fraud can also do, say, something like delayed 500 kind of thing over a period of time. So it'll try to find all the kind of anomalies, and then it'll try to see the fraud detection. And coming to the manufacturing, say something like, say if you have some kind of bolts, or some kind, if you're manufacturing some kind of nuts, so you'll try to see what are the kind of anomaly. So is it, if some kind of a machine it's giving, say continuously, or over a period of time it is giving bad sizes and statistics, like if it has the mean and variance is so long or so much, then you will try to see that there is an anomaly in the manufacturing. So you can use, if something is not working, you'll try to automate the process and say that, hey, this machine is not working. Maybe somebody should go attend and attend it. Okay. And then similarly, you have other options like e-commerce recommendation systems. Obviously, if you go to YouTube, you try to get a lot of recommendations, and each click you see, each video you see will actually improve the model much better, and you'll get much better recommendations. So that's what the use case is about. So what are we working on? So we are working, we're a health tech company. We are working on something called Truthin. So where, what is the idea? You take the packaged food data. Okay, so this is how our app looks like. So so what exactly are we going to do in this is like, so we have a packaged food. You click, you scan the barcode, and it will show you the product, and it will recommend you how much of. So for suppose if you have chocolates, so it will give you a personalized selection, like for diabetics, how much can they have? It's not like they cannot have any, right? Maybe it is 5 grams or 10 grams, maybe a piece. So it will try to tell you how much you can have, and how bad is it for your health, and how much is it matching for your profiles. So we take the complete data, like what is the nutrition values of it, and we'll try to regress some kind of data, like how much exactly can you have it for different serving sizes. And so this is our vision. So so more or less, by using this kind of artificial intelligence, we generally feel that the people can use good choices by using this app. So getting back to what we are learning, so when you're doing some kind of machine learning algorithms, the most important or most used Python program. So most of my development, so machine learning is not limited to Python. So you can actually do with many other mm, um, like software, say something like MATLAB has its own machine learning techniques. But why we use Python is because we have, say, something like Keras. Keras is a package which is developed by Google, and it is later integrated into TensorFlow. So yeah, as you can see, so this we have two kind of classification over here. One is the orange one, which is deep learning techniques, and the other which uses something like neural networks, say something like convolutional neural networks or RCNNs, etc. In those kind of things, Keras is the most kind of used right now, and these are the other ones which are actually used for the predictions of uh, estimates. So, what are the kind of three main problems that we can talk about? Is like so. For suppose if you're trying to see, so you have some kind of a data. Say you have will so supervised learning is something that you'll try to supervise. So if you have some kind of Gmail, okay, so you'll try to see you have it'll generally say that it is spam and this is not spam. Okay, and then you will try to see that the supervision that you will try to label them by saying that okay, this is wrong label, this should not go into spam, this should go into in my inbox, and this is an email which is in my inbox and it should go to spam. So you're actually labeling the data. From labeling the data, it will understand by itself, and when you come the next email you get, by the way you label it, by the time you label it, the model will keep getting better. So this is called supervised learning. And then you have something like unsupervised learning, and this there is no particular output, but more or less, for suppose if you are having different kind of customers, and then you'll try to cluster them into okay, what are the kind of behaviors or patterns that you try to see, and then you cluster them into groups, saying that okay, this group is the group that studies more, and this is the group that eats more. So that is the kind of classification it can actually do. And the other one is like reinforcement learning. So the reinforcement learning is more or less like if you're playing some kind of game, if you start a general game, say like something like chess, and if you're trying to play it, in the first time it'll lose the game, and the second time it'll understand. If you're using the same step, it'll try to use your different another step so that it can defeat you. So as you get along, you can see that it will find all the different kind of patterns, and it will reinforce itself to make the model much better, where it goes on the move. So you generally don't have a supervision like this is good email and this is a spam. You don't have something labeled like that. On the process, you label them and reinforce the supervised learning. So what is this supervised learning? So it is used obviously to predict the outputs, and it is you have some kind of rules, and the rules should be easy to understand so that you can extract the knowledge carefully. And then you have compression. So you will try to compress whatever with the data. You will try to get into some kind of metrics, and it will try to explain the data in a much simpler way. And then you have outlier detection. Say something like it is not covered by a rule. Then you can use say something like a fraud. Then you can actually, if it is not following the rules, then you can say that this is an anomaly. So that is supervised learning. So these are the classic applications. So you have in supervised learning, unsupervised learning, and reinforcement learning. In most of this, you have especially about supervised learning. So you have two different kind of issues over here. One is a classification issue. So you have say something like a set of uh, uh, choices, and then you should say like you can say like this is this a food good or not, or is this how much of this has to be taken. these are two different problems that we're trying to talk about. The first one is like the food is good or bad is a kind of a classification problem. You or say something like good, not good, too bad. You might have more than one options, and then it is still a classification problem. And we'll try to see more about the classification. But these are the kind of applications where you can see. So if you can actually pass, so you have neural networks, it will try to see. And if you have different photographs of yourself, it will try to read it and it will try to see. First, it will try to find the edges. So you have different kind of layers in the neural networks. In the first layer, you don't know which layer, but one layer might just see what are the edges, and the other layer can look into what are the kind of eye color or shapes and different kind of data. So these are the general applications that you can generally use for classification applications. Okay, so we'll try to understand the concept behind the supervised modeling or unsupervised modeling and how do we do it with a simple example. So you have generic data. So you have say something like say in London or somewhere. This is a classic example that people generally take. So you have say some kind of square feet of houses and what is the number of bedrooms and what is the price. So with this, if you have given another set of say like square feet and bed and number of bedrooms, you should be able to predict the price of the house. Okay, so that is the problem that we are trying to solve. Okay, so we'll try to see in the three different approaches of supervised learning and say like unsupervised learning, and try to see what exactly each of this does. Okay, for suppose this is the observed data and this is the new data. So you have say something like square feet and then you have bedrooms. From this you will try to see. So these are called the independent variables. Okay, so you have SFT that is not going to change with price, and bedrooms is not also going to change. So these are the independent variables. In the price you have to, so this is like X1 and X2 and this is like Y. So if you're looking into statistics, we're trying to say something like a regression of say like so we're trying to estimate the price. When you're trying to estimate price, it has a scale, it has different kind of values, and it is on a real number scale. So this is not just a classification problem. So this is a regression problem. So when you're trying to regress the price, these are the independent variables and this is the dependent variable. And you have the new data and these are the predicted variables based on whatever the kind of rule that we have. We'll try to see how these rules are structured later. Okay, and we'll try to see the relationship between the output and input as non-deterministic because it is important to capture all the factors that influence the cost of housing. So if you have say like a 3-bedroom house, so you have a predicted price of 26,000, it might not be perfect. Maybe the actual is say like 30,000. So here you're saying that you are under prediction. So you basically you're quoting less price than what is actually required. So if you're owner, you're at loss. So and the other case, say like if you have 1,200 SFE with 2 bedroom, the actual is 20,000 and the predicted is 24,000. In this case, you're actually over predicting it. So if you are a tenant, then you're at loss, right? So that is the kind of pattern you see that there is always error because most of the things are not exactly accurate because this is a prediction model and it works in with respect to probabilities. So it is not possible to say because this is not an equation that can be definite. So now we spoke about two different kind of problems, right? One is classification and regression. So we'll try to look into the different kinds of regression, right? So first regression, it's the output variable. What is the output variable? Output variable is a numerical value. So you have a lot of other variables, and then you're trying to predict from different kind of variable or parameters. So we say, so based on different kind of parameters, you're trying to find a particular value. So, and then you have binary classification. In the binary classification, say something like we spoke about, like spam, no spam. So that is the kind of idea that we have binary classification. And then we have multi-class classification. Say something like a classification of user reviews into positive, negative, and neutral kind of choice. So you have more than 3. And sometimes if you do opening Swiggy, they say like satisfied, very much satisfied, say like normal, and then they say that bad and very bad. So that is you can have more than 3 or many classes that you can talk about. And then you're talking about multi-label classifications. Then you can see that even within each label, there are further classifications. So say something like, say like what are the movie genres? Then you can say that there is an action movie. Then you can say that action, so okay, sci-fi action, or say something like war kind of an action. So there are different kind of labels to each set. So this is multi-level. So it's a multi-label classification at different levels. So we spoke about the unsupervised learning. So learning is like what normally happens. So there is no output for this because we are not saying what to do about it. It will try to find its own pattern and it will try to give some analysis. So it is generally used in clustering and grouping. Okay, it is generally used in the customer segmentation, the customer relationship with the management. Okay, and then it is also used in image compression. It will try to see the different kind of distributions of the color and it will try to find its own pattern. Okay, so this is what an unsupervised learning does. So we'll try to take up one say like example of see like how it clusters. So you have this data and you have from the data you're trying to cluster the data. Then you can see that it is clustering bigger house with less number of bedrooms. It will try to see what is the SFT, and then you can see less number of bedrooms, and you can also see it will try to see what are the based on SFT and the number of rooms. It will try to classify something, and then you have a bigger house with more bedrooms. That is one kind of a classification. So it is clustering into this thing into 4 different uh, data sets. Okay, so unlike the supervised model, so this unsupervised model do not have a particular output variable. So when you're trying to model a particular kind of situation, you'll always see that there are different kind of variables present. For suppose you can see that like height, weight, okay, and so you have your age, okay, and then you have other data like where did you stay, etc. Different kind of data. So you'll have when you're trying to build a model, you'll have to see what are the variables that are necessary. So sometimes the variables are unnecessary. So if for suppose where do I sit every day? So if that is there in the kind of data, so it might not really help. It might, so it is impossible to capture all the kind of scenarios, variables that are actually affecting a particular outcome. So that is not really possible. So you'll have to cut down your variables to a particular limit. Only then you can work on it. Right. So if you are actually modeling, sometimes you can have say something like, if I'm actually looking into say like how am I doing in my education with different levels, and if you're trying to see that my marks in maths 1 and maths 2, say like physics and chemistry, these are the kind of subjects that I have, and you see that maths 1 and maths 2 are consistent. You're getting different, you're getting good grades in maths 1 and maths 2, but physics and chemistry is like little poor. So if you're actually looking into this, you can see that there is a high correlation. So you have, if you can look into the rank correlation or some kind of proper correlation, you can see that both of them are actually very near. So that gives a bias on how you're doing in physics or chemistry. So if you're talking about maths, physics, and chemistry, maths 1 and maths 2, taking 2 data sets, it's actually giving a bias. So you have to see and cut down the parameters based on some kind of a statistical parameters is something like correlation, etc. And then in some cases, the variables are utterly unnecessary, so which need not be used. Okay, so you'll try to reduce the dimension and then select your model. Okay, more or less, you'll try to say something like, for suppose for the given house, the model that we're talking about. So if it says like this is the length of the house and this is the breadth of the house for all the houses, so nobody actually looks into say like length and breadth of the model. So nobody looks into it, right? So basically, everybody looks into what is the SFT, what is the area, what is the usage area, or different kind of areas, but they'll try to only look into the areas of it. So there is no point of studying length and breadth. So if you have length and breadth given separately, you will try to multiply them and get another new parameter which is actually used, and you check out all the old data, say something like the length and breadth of the rows. Okay, so that's basically the dimensional reduction. So how we can actually, because lesser number of models, when you're actually looking at it, it's much easier. Or else you need to have bigger and bigger servers which we deploy on AWS or say like cloud. So the other thing that we spoke about is this reinforced learning, right? So what is this reinforcement learning? So you have here also you don't have supervised output, but it has a delayed reward. Say something like after every step, okay, this is right or wrong, and then if after next step, it'll try to say right or wrong. So it'll slowly get better and better and better, and it'll finally make much better uh, predictions. Okay, what does the generally think? So if you, how good is the state of a particular policy, then you can actually see that within the policy you'll try to see and enhance itself. Okay, and then you have a credit assignment problem. So you have what is the kind of credit it has taken, and okay, is it giving a good output or not, and then you can try to give the feedback and improve the estimation. So statistical modeling. So when you're trying to look into it, so what are the different kind of uh, steps that you generally look into when you're actually making a statistical modeling or the machine learning model? So how exactly the statistics is used? So you have a basic representation of choosing a relationship between the input variable and the output variable. This is very specific, like how is it linear? Okay, so or it sometimes it can be non-linear. It's non-linear cases, it is very different, and you have to carefully fit in all the cost functions. And then you have a cost function, which actually evaluates the model performance, and it's also called a loss function. So you'll try to whenever you try to construct a machine learning model or a different kind of prediction model, you'll always have some kind of a statistic which you have used in general statistics. You have say like Z measure or different kind of statistics, right? So F statistic or Z statistic or different kind of based on the kind of model itself, you have to choose the different kind of models. Does it have to be is it a normal distribution, or it is say something like a if it is discrete, it's a Poisson distribution. You try to look into the kind of possibilities of how exactly your cost function should be, because depending on its distribution, the cost functions might vary. So you have to be very careful while you constructing these cost functions. And in the when you have a cost function, the idea is to optimize the cost function, and then you have a minimum loss. So that is the kind of idea. With that, if you minimize the cost function, then you have a better model by yourself. So in the earlier example, when you're looking at it, so you have a rental prediction or a prediction example. Say like this is the price, and X1 is the SFT, and X2 is the number of bedrooms. So now this Y is our dependent variable that we have to estimate, and epsilon is what we have for the error. Okay, where beta naught is some kind of when beta 1 and beta 2 are 0. So basically, it should have what is the minimum kind of value that it should have. That is like beta naught, and and yeah, epsilon is the error. So more or less, we want to minimize. If you have to have this error to be minimized, then you have to minimize the function of y minus beta naught and x1 beta 1 and x2 beta 2. So out of this is the predicted value. So you have some kind of a realistic value, and from the realistic value, and this is our predicted value, the one in the underline, and then you'll try to minimize that function. That is the idea. So, in case when you're talking about the earlier example, then you have under prediction and over prediction, right? You have two cases. One is 4,000 rupees more, and the other one is 4,000 rupees less. So, either of the cases, it's not really good. So, how do you actually take the function or the cost function? Is that you take the difference. So, yi is the actual price. Okay, and y hat is the estimated price, and you try to take the L to top of it. Say something, you try to take all the errors, add all the errors. So why not take a simple y minus y hat? Is that, so for suppose if you're trying to regress some kind of line, okay, so it starts with a general linear regression. So you have some kind of points on, say like two-dimensional plot. So you have all the dots, and then you'll try to find a line which is optimized when you're looking at all data points. Okay, So in that you have some of them, as you can see, some of them can be positive and some of them can be negative. If you like to see what are all the errors in these two cases, if you actually add, this is plus 4,000, here the error is plus 4,000, and here the error is minus 4,000. And then you add it, then you see that there is no error at all. And it is not correct right measure. So what you try to take, so you generally try to take, one method is to take the absolute value. Okay, minus 4,000 is an error, you take 4,000, and plus 4,000 is also an error, you take 4,000, and then you add them up. But you can see that taking the squares and adding them is the best way to find the error, and it is easy to find the optimized values for this. So once you have this yi is nothing but whatever we have given here. So this is the estimator. So this is y hat, to be very specific. And at each point you have a predicted price. Now, once you uh, take, how do you actually optimize the algorithm? So to optimize the algorithm, you basically, obviously, what is it that you have to find? You have to find or beta 1, beta 2, and beta naught, right? Because x1 and x2 are the variables, fixed variables that you cannot change. Okay, and y hat is the estimator, so you have to predict it, and apart from that predicting this y, you also have to find the optimal beta 1 and beta naught, beta 1 and beta 2 variables, um, or more or less the model parameters uh, for the function. So for that, you have to take the derivative, partial derivative, or so to be specific, this should be a partial derivative. So you take the partial derivative with respect to each of this, and then from each of the cases, you'll try to solve them and get the beta naught, beta 1, beta 2. So beta 2, sorry. So when you look into this, so sometimes it can be a simple, it might look very simple that it is a mathematical problem, and if you take a partial derivative, you can solve the equations. But getting the solutions is very difficult, because it might not be, we might not have a method in mathematics right now which can exactly solve this. So we generally go into numerical methods of, say like, um, say like Newton Raphson or different kind of other methods where you actually find these parameters by using a numerical method. Okay, so that's how we optimize the cost function. Okay, and then validation, right? So you have supervised learning, and then in the, how do we actually validate the data in supervised learning? In supervised learning, we have, what you have is particular data set. In the particular data set, it's already labeled what is right and what is wrong. You have a complete, says we call it the training data, okay, and then we have a testing data. So you have a complete data set with all the values labeled. So what you try to say, how do you actually say the whatever you have predicted is right or wrong? You need to have some other label data. So for suppose if you have 100% of data, then you try to put, say like 70 to 80% in the training data, so that you have more data and you have a better prediction model. And then you'll test it on this other 30 or 20% to see how many of them are exact right or wrong. Based on that, you can say, you can actually say talk about the accuracy of your particular model, right? And this you have train and test split, and then you have k-fold cross validation. So we'll talk about each of the cases carefully. Okay, training and testing split model. So you have a training set. So we have, this is the overall kind of data, and then you're trying to split it into, say like one chunk, and this is the other chunk. Okay, so you can see that you can see different kind of noisy patterns when you are actually training the machine learning model. So, but over a period of time, you'll try to see that it is getting better and better, right? And because it depends on the kind of data you train. Okay, especially with the big data, and it's the over data will also be a problem, because there might be different kind of predictions, and it might be very erratic. Okay, you have to limit the data onto itself, like what has to be trained and what is not. Okay, yeah, and this is used for the testing and training data. So when you're talking about k-fold cross validation, so you have, in the last case, what did you have? So you basically had different kind of chunks. Okay, so you have particular one big data split into say like 30% and 70%. And in the 70%, you'll try to see, you'll try to train the data and touch on this 30, right? So this key-fold validation is little different. So what you'll try to do, for suppose if say like the k-fold is the number of folds that you take. So if you're taking a 5-fold, so this is an example for 5-fold. In this 5-fold, you'll try to see what is the training data. You'll try to divide it into say like 5 sets. In the 5 sets, you'll try to take the first 4 and say like leave the 5th one for testing. And in the second case, you'll try to do and get a score of how accurate is your prediction. And in the second case, you'll try to use say like the 1, 2, 3, and 5 and leave the 4th one out and get the accuracy. So if you are getting consistent accuracy in different kind of chunks, and these chunks, how do you actually divide these chunks? So that has to be random. Even in the case of say like the 17 and 30%, you should not really take this first ones and the last ones. You have to take the random values and you have to randomly split. So this is also randomly split. So after you're taking 3 or 4, so 5 folds, you will take it 5 times, 5 different sets. And then you will try to predict the data on the other folder. If you can see the metrics are consistent, then you can expect the model to be better, because on different training and different testing data, you're actually getting a different metrics. So the other one that you talk about is, so when you're actually looking at the complete data, so sometimes you might we call it the training, testing, and validation. So you generally do not take the 30% exactly for that. So you have first 70%, and the first 70% it is actually trained. The other 15%, the first 15% it is used for say like validation. Then you can say that this is the score of our algorithm that we are talking about. And in the second case, the other 15% that we are actually testing the model, that's called the validation, that whatever score, the accuracy that we have on the testing data, is it being consistent in the other 15% or not? So that is the complete idea of how you do the validations. Okay. So if you have any questions, you can ask me right now. And and I was thinking, if there are no questions, I'll go ahead and present a simple example on say like a general problem. Any questions at this moment?
Dear attendees, if you have any questions, please raise the hand. You can raise the hand here.
Any questions? No, right?
Dear Praveen, please go ahead.
Yeah. Okay. So this is a general kind of problem, very generic problem that you can see it in different kind of places. So what is the data set is like, you have this is what we are looking at now is like, so till now we have actually theoretically seen the different kind of what models, like we have machine learning models, and how do you actually construct the cost function, and how do you optimize it. But in real life, you actually don't use all of this on a general basis. Okay, if you're in academics, definitely you'll have to do it, because you'll have to improve the models. And you definitely have to have a proper understanding of how different kind of models work, but you don't have to delve too deep into it. So this is what I'm using. So I'm using something called Jupyter Notebooks. So this has a Python backend. Okay. So if you can, let us talk about the problem. So you have a Titanic dataset. So this is very famous. So you have Titanic sinking, right? So when it sank, so you try to see, so basically they have a data of how many people, passengers are there. You have a passenger list, and after the passenger list, how many people died. So if you're talking about, if you're predicting, say, something in a seat, if he's sitting there, what is the probability that he would have survived or not? Because the statistics are not, because you don't have statistics for all, you have the results for all the people. So you have only for some of the data, and you have to predict the possibility of the other person's survival through this. So that is the exact problem. So we'll try to look into how statistics or different kind of metrics are used to understand the data by itself, and then you construct the model. Okay, and now for that model, what kind of parameters are being taken. Okay, to do that, exploratory data analysis is the key part. Okay, so and building different kind of machine learning models and further evaluating of what is the correct thing. And if time person permits, we'll try to talk about how the further evaluations like confusion matrix, the F score, etc., or the precision recall curve can be used. Okay, so this is the RMS data. Okay, so we have some kind of data. So in this, we have a different kind of packages. So most of the packages are there. So we use for vector operations or like NumPy operations, say something like float operations or different kind of operations or the matrix operations. NumPy is one of the good libraries. It is very fast and it is backed from C, so it is really fast. Okay. And so when you're talking about Python, Python has libraries both from say like Fortran, C. It suppose it has backends from different kind of languages. Okay. And then I imported Seaborn. This library actually helps me in visualizing the data much better. So we have other data, something like this, and we have something like sklearn. So this is called scikit-learn. This is a very famous package where you have different kind of models inbuilt in it. So you try to import all the models and then maybe tweak it or tweak them to make your model much better. So you have further arguments into this, but you can use it directly. In this case, we are using it very light, so because it's a very particular example. Okay, so what is the data? So you have say like a testing data and you have a training data. So from both of these data, you'll just have to see what is how do you can predict if a particular passenger uh, can is alive or not, like survived the Titanic crash or not. So these are the when you look into the data frame. So we call it the pandas data frame. Pandas is one of the most powerful way to actually look into the data systems. Okay, so so these are all the columns that are actually used for that. So we'll try to look into different kind of data. Okay. So we'll start with exploratory data analysis. We'll try to see what the data is about. So if we have something like an info command, we look into what are the different kind of columns. What is the general thing? So you have passenger ID. You can see that how many total number of entries. The total number of entries is like 891. So you have data for 891 entries, and from that you have to uh, say you have to predict the data. This is in the training data. Right. So how many of them are non-nil? So you have 891. All of the passenger IDs are given. Okay. And you can see survived how many people survived. This is also given. This information is also given. And if you can see, the age is only given for only some people, and it is not. And the cabin numbers are only given for say like 204 or something. So in this case, I can see that this data cabin number is only for 204 people, and we are trying to look into a data set of 891 people. Maybe taking a cabin number might not actually help me at all. Maybe that gives us some kind of bias. I'm not very sure at this moment if I can use the columns or not. Okay, and then what are the other examples? If you can see, so these are the survival and these are the meanings of the columns. So survival is survival. Passenger ID is like unique ID of the passenger. Peak class is like what the class. So like you have three types, 1, 2, and 3. So like we'll try to see what passenger class is that. Okay, and then you have your gender, and then your age, and then the like, sibling and SP is say something like how many if a particular person is going into the Titanic ship. So we'll try to see if there are any siblings. So if because you have siblings, there are good chances. If you have like one or two siblings, maybe they'll try to find a boat and maybe send you in that. Say like if you are female in gender and somebody from the male gender is maybe saving them and putting them into the board. So these are different kind and if there are say like 5 siblings, say like, so maybe not all of them might find one single board. So they might not actually, they might be looking for another life board which will take all 5 of them, and they might not find a board and they might die. So there are different kind of scenarios. So the sibling person, if you have a sibling, it doesn't mean like you have so there is, so the objective of the complete regression or the kind of estimation. So this is a classic classification problem. So you have survived and not survived. These are the only 2 states possible for a given thing. So when you are looking into it, so then you also look into another object, say something like um, what is how many are like parents or child. So if you have parent or children, you cannot leave your children and go. So that's a different kind of maybe. So what we're not trying to reason out what would have happened. We're trying to see the parameters. Is the parameter making any relevance or not? So similarly, have cabin number and embark. So embarkation is like where did you actually get into the things. So then you have a dot describe. This is a simple thing that will actually tell you what is the count and what is the mean and what is the standard deviation and all the quartiles, or what is the 25%. Basically, these are all the quartiles, right? So we'll try to find all the range. So you have the range and standard deviation, everything for all the columns. So you have the passenger ID, in that how many have survived and what is the mean survival, or say like if you take 0 to be say like dead and 1 to be survived, so you can get a mean. So this you can see that it is in between 0 and 1, right? So that is a kind of survival. So it will try to give you some kind of an idea. Okay, so like maybe 38% of the people survive and the rest of them will like die. So that is what you get from this. You can get some kind of insights from. So this is the training data, the complete training data that we have already seen, right? And yeah, so you can see what is the total number of null values. So you can see the total highest number of null values are in cabin numbers. So you have 681 values, and you might not yeah, that might be a giving a bias. And then age, you can see that 177 of the places the age is not given, and then how many embarked is not given, it's only 2, and the rest of all the data is there. So looking at it, I can see that embarked 2 places data is missing. No, you can try to take say something like where most of the people have gotten the ship. You can take the same thing, and I can actually estimate. Maybe age also, maybe to an extent you can estimate, but the Kelvin number is way too much, right? Um, and then you look into the kind of percentages. What is the kind of percentages at each stage? So what is the number of null values with respect to the complete null count? So if you can see, out of all the null values, the cabin is 77% of the null values of the complete data set, and then the next highest is age, as we have seen. Then you take the percentage, and then you'll try to see you can actually get them into one place, and then you can see the data. Okay, so these are the kind of values you can see that like column values. So these are the columns that you can see. And what is you have 11 features. Out of the 11 features, you'll have to optimize and see and reduce your dimensions in such a way that you make right prediction. So suppose if you're taking ticket, or say like it might be a first class ticket. Maybe if it's a first class ticket, maybe it makes more sense. Maybe the fare might not really help you so much, or it might help. So we just have to find the correlation for each of the things. Okay, so when you have survived and not survived, these are the classifications that we're talking about. And then we're trying to see, visually see what, how many people survived and not survived with respect to men and women. Okay, you're trying to slice the data by taking a particular variable. So here you're saying the sex is female, And then obviously that is women. And for women, how many women actually survived and did not survive? And maybe for each age, so this we are using age bins. Okay, you will try to see that this is what you see. If you can actually see that from the statistics, that you can see that most of the female from say like 5 to 10 years died a lot. Okay, have not survived. And whereas the people among say like 20 to 30 are actually have survived more. So you can see that there is not survived people are very less, but at small ages, say like especially from 5 to 10, a lot of people die. And similarly, if you can see the male people, the most of the people who died are in between say like 20 to the 40. So a lot of people died, and the survival rate is more of the children and not the elders. So this is the kind of statistics or insight that you can see and derived for a particular instance. So you can see that how many people. So when you can, if I'm, and then you will try to see the embarkment. So where the person has there and what is the passenger class and how many people survived. That I want to see. So I have another data set where you can see that received. This is the embarkment C. So this is embarked S. So you have three stations, and so I'll try to say it with S, C, and Q. Okay. So where the SC and Q are say like port Q and port S have a different kind of survival rate. Okay. We're trying to see how it is there. So for male and female. So the people who got into the ship at a point C is like you can see that female is more the survival rate of female is more than the male. Okay. But at a port Q, you can see that the survival rate of say like the male is more than the female, and this tried to give the kind of age difference or the kind of data, right? So this is um, with respect to the other data, and this is the number of survived and not survived amongst male and female for a particular passenger class. So this is 1, 2, and 3. What are 1, 2, and 3? These are passenger classes. In passenger class 1, how is this behaving, and like how is the distribution? And passenger class 2, how is the distribution? So we'll try to see for a specific passenger class how many people survived or not. So, like for passenger one class, you can see that there are one number of percentage of people who have survived, and passenger two, there are less number of people, and passenger three, it is much less. Okay, basically, the kind of tech system is say something like you have passenger one will have the top what bunkers, and then the second class will have beneath that, and the third class will be further beneath that. So if the ship is sinking, they have to come up all the way up from the bottom to the up. So that is the kind of idea out. Okay, and then you have a grid. So you have a phase grid. So you have different kind of survived with respect to class. Okay, with respect to each class, how many people have survived and not survived. We're trying to look into the statistics, and then you can see that passenger two class survived people are less. Okay, that is why we have survived is equal to 0 or 1, right? So that is why we had that average. So you have some people, number of people who have survived in the passenger class one, and then class one with who have survived and not survived. The number of surveyed looks to be more, right? It is very visible on the screen right now. So, and for suppose if you're looking at passenger class 2, the people who have survived and not survived. So you can see that survived, if it is say like 0, you can see that there are more number of people um, who have died than survived. Okay. And that you can actually see in passenger 3, you can see the clear difference, the number of people died with respect to age. So the younger people died a lot when compared to the younger and elder people. And this is the kind of distribution that you see. It is very evident that a lot of passenger, the percentage of people who died from the passenger is much more. And then we spoke about the sibling parts. So we'll try to see if you have siblings and parts. So here is what we're working on. So if you have siblings or parent and children, you can call them as relatives. You can actually reduce the dimension by taking two columns into one. Say like say something like relatives. Okay. So that reduces the complete dimensionality of it. And then you have for a local data sets, then you will try to see if it's greater than zero is not enough. So if it is exactly equal to zero is more or less enough. Okay, so that is what you're trying to find out. And then you'll try to see the relatives if it is actually doing any better. Okay, so you have relatives, and that you have 0, 1, 2, 3, 4 relatives, 5 relatives, and you can see at different points, you can see that the survival rate is very less over here, but it is more if you have one sibling, then somebody is trying to save you. Maybe you have three siblings, it is highest, and then if it goes to 4, 5, you can see that it is keep decreasing. So this is a statistics from based on what statistics and the people have survived you have. So this is the kind of idea that you have. Okay, and then we have so now we have actually looked into the exploratory data analysis of okay. Then from the data and the statistics that we have studied, we have actually cut down one set. Okay, but later we might actually look into and improvise the model. Once you put so this is the kind of idea, right? You will try to design an algorithm. Okay, with a given set of parameters, you look into the kind of predictions, and then you try to take the feedback, maybe look into maybe if you can actually modify the model, and then you can get a better precision by the modification of the model. So right now we thought that these are the ones we'll try to drop parent, child, and the siblings, and instead we'll try to take relatives. That is one thing that we did, and we try to see if there is any correlation between everything. Okay, right. So what do we do with the missing data? We always start, right? The first is the two embarking are missing. When the embarking is missing, we will see that what is the we'll go with the mode and say that what is the most frequent. We'll go to and we'll say for suppose if it's from San Francisco, so we'll put all the people from the San Francisco. That is the idea. Okay, so if so, when we are looking at it, first we thought that C123, no, so it is actually referring to the tech. So maybe out of this 200 people, maybe I can get a metric. So this is how the Titanic looks like. So it has a different kind of layers, A, B, C, D. So it has a different kind of floors, and this is the basic engine. Okay, this is the engine feeding coal feeding room, and these are the turbines, and these are the other texts that you have. Okay, in that you have from ranging from A to G. So maybe when you have the data for the 217, maybe I can draw some insights. This is another idea because looking at the model. So that this actually is an example of how important your domain knowledge should be. Now we have done statistics, and then we have to use the domain knowledge to get it much better. All the while, you have to keep to get the right statistics. You have to use the right algorithms all the time, right? So that you have to do. So in the C123, I'll try to see what are the kind of in 217 people. What are the different kind of people in the decks you have? Out of that, I'll try to find out how many people from A, B, and C and D till G column X are survived or not. So that kind of statistics I can get, and that I'll try to. So that is I'm trying to do. So with the data that I have, with the training and tester, so the complete data. So the training data and testing data I'm putting into one data set, and then I'm trying to see fill all the datas, and I'm trying to find if there is a deck number given. Sometimes it might be just a number. So the data is not always given. That is the most difficult thing that we look into when you have a particular set of data. So if you are like C123, the C will tell you that it is from the deck, and 123 is the ticket number. Sometimes you might just get 123, then it makes no sense. So when you're trying to see or extract text patterns or different number patterns or any kind of patterns, then we regex is one thing that is used across Java and other platforms. So in Python also, that's a very powerful tool to extract data sets or the patterns. Okay. So similarly, so here we use regex. You can use a regex to find all the mappings, and then you can see wherever it is not there, you can actually say like fill it with 0. And then say if you have different and yeah, so that you can actually do. So similarly for age, you have different statistics. You will try to see what is how many ages null. So you can all see that it is nothing. So there is no missing. So similarly, you have embarked how many of them missing, but there are only two. So this what is the most common value? So you can see if you can actually look into a particular description. So earlier we described the complete data frame. Um, I mean the data set. There we have a different. If you're looking at a particular column, then it will tell you what is the number of count of non-null values, and out of them how many are unique. So you have only three. And what is the top? If now you know that this is the most common value is S. So for the data, wherever it is missing. So wherever it is missing, I'm trying to put the common value. So that is what I'm trying to do. So basically, we're trying to do the mode thing, right? So now we have to convert the features too, right? You have relatives and you have also seen not alone if it is. So once you have the parent child and the siblings, from these we have derived the relatives. From the relatives, you're actually seeing if you're alone or not. So that's a 0-1 classification that we have. And we have got from whatever we have improved, we have increased the number of columns on the data set. Now, once you have the data set, then you'll try to see the fair. Okay, fair, we can always fill it with 0. Okay, or else because we don't know if it is actually doing much of things. So we'll have to see if there is any issue like that. But more or less, you can also fill it with, say, like if you have data. So it depends on the kind of data. So if you're actually going from one person to other person in general way, so the missing data is handled by taking, say, like the forward fill or the backward fill of the data. Okay, and then you have titles. Maybe the title, for suppose you have different titles, say like Miss or Mrs. or Mrs. So you'll try to see Miss title is for the people who do not get married. So you'll try to see how the young women behavior is actually there. Then you can see the older behavior. Then you can also see the rare ones. What are, say, like something like Mr. Praveen or Dr. Ravi, or say something like that, or say something like Captain. Okay, if it is given Captain or say like Sir, there is good possibility that they'll get into the lifeboat first and they might live, right? If it's a scientist or a doctor, there are other chances for that. Okay. So what are the other titles? If you have other titles, then we are trying to say that lady, countess, etc. They all actually go to one. So you do the basic data cleanup. So this is the data cleanup part. So you might get you generally get dirty data, and you have to actually look for it. Okay, and you have to clean it and make it predictable so that you can use it for analysis. Okay, and once you take the title, okay, name the name doesn't really matter, right? The title matters. Say something, if he's a captain, then you can say, but the complete name might not actually help me at all. So only I'm taking only these titles, and then I'm trying to see, because if you take the name, you can actually classify the data. Okay, and you cannot make any prediction, because for each row the name will be different. So you take this. Similarly, you'll try to say look into what are the different kind of genders, and you can try to classify them. So this you will have to do for each of the cases, and see what are the how you can actually what data is actually seeing. Okay. So and then once you have, if you have the age, okay, and if you're trying to see, you cannot really predict with the complete age. So what you'll try to do is like you'll try to make some kind of bin. So like less than 11. So these are children, and then you have say like adolescent, and then you have youth, and then middle youth, etc. Right. So that's the kind of classification I'm trying to see. And with different kind of bins, these kind of sites, I'll try to see the data. Okay, this is the age counts that you have. Once you have once you have the age bins, then I see that the 891 data that we have now, it is classified into these columns. So fair. So I was looking. I'm actually looking if fair actually means anything, and it says So for the fair, if I do a similar kind of analysis, so this is the kind of data that I have. So more or less, I'm trying to convert all. So for suppose this, we have some of them are numbers, right? Age is number, fine. But I'm trying to convert, say, like these ports, so like S, C, and Q, three different ports to numbers. So the complete idea is like even if you have strings, so for suppose if you have male and female, you are putting into 0 and 1, if you can see it. And here you can see Mr. I'm giving 1 and Miss I'm giving 2. So I'm trying to give numbers for all of this so that once I have all of this, then I can use say some kind of number. So the ultimate idea is like when you're trying to estimate, you'll try to give a mathematical numbers for each of the variables, and then you'll try to look into the prediction. Okay, so that is what about accelerated data analysis. And if I think it is 10:25 right now. If I have more time, I can continue. But I think I haven't
Yes,
made.
sir. We have time, sir. No problem. That's a good
Okay.
application. In fact, we are enjoying.
Okay, thank you. So similarly, we can actually create new features. Say something like age versus class. You will try to see. Okay, so I'm trying to construct more variables. What is this? So I'm trying to reduce the dimensionality. So I'll try to look into more into it. So I'll try to combine age and class. Okay, if it has anything or not. I'm trying to just guess. So fair per person. So you have the complete fair, and what is the fare for one particular person? Because you have one ticket and then you have many names under it. Then you'll try to find the data sets. Then you'll try to what you can try to take is like you can see what the number of relatives you have, and then you can divide the complete fare and then maybe get an estimate. So similarly, you can that might be a good thing. Maybe we don't. So we'll try to look into that too. So as you can go ahead, so you can see that we are getting all the columns one by one. So you have age class. These are the numbers that it represents, and we'll try to see. So now you have different kind of patterns. Okay. So from these patterns, and we have the training data. So training data is very much given. So this is a Kaggle data set, like I told you. So from you have the training data test and Y training. So what is the X training and Y training is like you have the complete set of data, and the last column in general is the dependent variable, the one we spoke about in the presentation. So you actually have to find this Y hat given this Y. So this is the exact Y. And from this, you're trying to cut the testing data. So you have testing data similarly for that. Okay. So the models that I'm going to build are like stochastic gradient descent algorithm. So this is one algorithm which is a very good classifier. So you'll try to see the different kind of iterations. These are the parameters or options in this. You can see that this itself is the complete machine learning code that we are actually building. So there has been, we have hyped machine learning so much that, but you actually see that it is actually 3 or 4 lines. So if you actually see the complete data modeling and maintenance, you'll see that only 5 to 3% of the code is machine learning. The rest of it is maintenance of databases and how do you make your training files and how you maintain your training file databases, and what data has to be checked out, what data has to be taken. So if I'm actually say like in statistics, that's a very basic example of say like uh, uh, if you have to say like what is the average height in India, then you cannot actually go to a basketball or like basketball, and then they say that the basketball players are like 7 feet, so the average feet is 7 feet, because that is not justified, right? Because the data that you're taking is should not be biased, so it has to be very normal. So you have to see out of all the training that data you get, because you cannot. So even if you're using a lot of training data, it is not feasible. How much there is a limitation for your tries, there is a limitation for everything of how you build your models. So it has to be very carefully seen and clean. Okay, so but when you're looking at a machine learning model, we generally can't say for sure that this is actually giving and this is not. But you can always expect one to be better than none. But it definitely differs from case to case, and you should not jump into conclusions, or you should not jump the gun when you're actually taking decisions. So apart from stochastic gradient, so stochastic gradient is takes a kind of estimator, so it will take. This is more or less is something like if you are familiar with numerical algorithms. This is very close to Newton-Raphson kind of numerical algorithms. So where you actually take the first thing. So when you're actually looking into or constructing a model, like a particular kind of method, okay, then you have to have a complete idea on distributions, and you also have to have some kind of information on the other data models. And then you have calculus and statistics are very important, because you have to take the partial derivatives, you have to solve, and then you have to have good numerical methods which can actually find the solutions for this. Okay, so but if you have to implement the models, you don't have to have the knowledge of all the mathematics or the calculus. You just have to see if you are actually making sense. Now, in this, if you can see whatever statistics or whatever we have done is very plain and simple. This is understandable by anyone. So you're not using actually complex calculus or any statistics, different kind of metrics. So most of them you have say something the simple packages. If you can use the simple packages, it is very used to get easy to get the kind of idea. So if we can see the accuracy of the stochastic gradient descent algorithm is like 76%. And then you have for random forest, this is another thing. So you try to do the most of the code is also same. You just have to change the kind of estimator. Okay, and then you have 92% accuracy over here, and then you have 81% for logistic regression. Okay, and then for K neighborhood classification, which is also called as KNN, it is 87%. And for neighbors classification, Gaussian classification, it is 78%. And for perceptron, it is 75%. And for like linear SVC, it is 80%. And then you have decision tree, you have 92%. These are the different kind of models. And then what you try to see, you try to find the best model and judge that this is the perfect model, right? So that is what we're going to see. So you have all the models. So they like SVM or model is the support vector machines. And then you have KNN, logistic regression, random forest, and you'll try to see, and you'll try to compare the scores. Now you can see I've made it into a table, and then I try to sort it on scores. Then you can see that this is the score, and the best thing that we have seen till now is like random forest and decision tree. So far, for the validation, so that we have built the model right now, but you have not looked into the validation. So you have so basically you have training data and testing. Training data and testing data. From the training data, you train the model. On the test, you actually test. But how do you actually know that it is being consistent on the different kind of sets you have? Okay, right now, because of, other than the training and testing data, you don't have any other uh, values, right? You don't have any other data. So if you take complete new data, you don't know the outcome, so you can never say. So that kind of data is not usable for validation at all. So for validation, you need to have some kind of label data, say something like testing data. Okay, so for that, for now I think that random forest is the best. Okay, decision tree is also very good. So because both of them have the single kind of score when it comes to this. Okay, for validation, what I'm going to do, so I'll try to see the k-fold validation. I'll try to take in different kind of folds, say like 5 or 4 data sets, like same as before, and I'll try to see the data from it. So now I'll take the classification. When I'm looking at the scores of k-fold classifications for all the classifiers, for different kind of classifiers, I'm trying to see the scores of the k-fold, and I see. So I'll try to get, say, like for 10 folds, I'll get these many data. From this, I'll try to take a mean and say that that is my mean score, or like that is a consistent. So which is much better than working on a single test data set. Okay, so that is what I have for all of these things. And so then I have more about random forest, but I think and fun with the time. Yeah. Any questions you can ask?
Yes, sir.
Uh,
Um, that's really a wonderful session, sir. Particularly, I am very much enlightened by your informative talk. We have also actually included Python programming recently in our probability statistics course. And this talk really helps us in adding good examples and applications while we teach the students. That's a really helpful talk for every one of us, sir.
Thank you. Thank
And Dr. Praveen, I request that I have got a request from the participants that they're asking you, if possible, can you please share the data set?
Oh, sure. That's not a that's if you go to Kaggle and do a simple registration and check for Titanic problem, there are
Okay.
data sets available just like that. That's an open data set. That
Okay. And
yeah,
what
I
about the
can
code,
share you
sir?
the links. No issues. Yeah.
Code.
Code. Okay.
Okay. Thank you, sir. Thank you very much.
Sir, I would like to take a few questions from the participants, students or participants. If you have any question to Dr. Praveen, please use the raise hand option available to you so that I can allow you to unmute yourselves. Okay, sir, I think students are hesitating to ask you a question, and if you provide us any of your mail ID, students may contact you directly.
Sure. So let me just okay.
Or you can use whiteboard otherwise.
Yeah. No, I'll just put
Text it.
this, yeah.
You can text in a message box, sir, so everyone can see that.
Yeah. Actually, I'm trying to do that. So this is my personal mail ID. Okay. If you have any queries, I think you can see it, right?
Yes, sir.
If you have any questions, you please mail me.
Yeah. Dear participants, you can see the mail ID in the chat box. And if you have any queries related to that, you can please don't hesitate to message or mail to Dr. Praveen. He'll be always available actually for us, especially to the SR University. He'll be available.
Yeah.
And sir, you were into the academics and now in an industry. So in your opinion, sir, what statistics concepts we should not miss to include in our curriculum, sir?
Actually, this is now you're into research, right? So you understand that the problem is a problem. You cannot differentiate that, okay, this is a maths problem or a physics problem or a biology problem. You take up realistic problems, try to approach them, and you have to do whatever is needed. So, but yeah, our curriculum, I have seen the SR University curriculum, and I have set the papers once or twice when I was in BIT. So I know the standards of SR University. I think you're doing a pretty good job. So, but like you said, right, you introduced Python now and you're teaching them. So they're taking up real life examples to see how this can be classified and done, right? So that is the interesting part for even for the students. So if you have more projects coming up, that's more interesting. So implementation is more important than learning. Right? That's the idea.
That's a good one. And students, still, if you have anybody wants to talk to Dr. Kashyap. Okay. Sir, otherwise, now I would like to call Dr. B. Ravinder to propose vote of thanks.
Sorry, you're on mute.
Okay, sir. Dear all, very good morning. I want to express my sincere appreciation to our distinguished guest, Dr. Praveen Kashyap Garu, who shared his profound insights in the expert talk on the role of statistics in machine learning. It has been an incredibly enlightening and thought-provoking session. Our guest expertise in elucidating the intricate relationship between statistics and machine learning has undoubtedly added immense value to our understanding. His ability to simplify complex concepts and make them accessible to a diverse audience in a commendable. I would like to thank our Associate Dean and Head Department of Computer Science and Artificial Intelligence, Professor Shashikala Garu, for her continuous support and encouragement in organizing such events. It is indeed a great delight to thank our management and VC for motivating and supporting in conducting this kind of webinars and expert talks, which certainly help the students community. I would also like to extend my gratitude to the audience for their active participation. So your enthusiasm and activeness contribute significantly to the success of such a knowledge sharing events. Also, it is my pleasure to appreciate the coordinators of this program, Dr. Suresh Reddy and Dr. Ravikiran, for organizing such an important talk and introducing an industry gem to our university. In closing, a special thank you to our esteemed guest for his talk, expertise, and passion for fostering in the importance of statistics in the realm of machine learning. We are truly fortunate to have had him with us today. Thank you all for being a part of this insightful session. Thanks for your participation